All right, so again, page 572, we're working on example 5. And what we're going to be doing today is using trig ratios to solve a triangle. Now, what solve a triangle means is to find all the side lengths and to find all the angle measures. Okay? So, example 5 says solve the right triangle. Round side measures to the nearest tenth and angle measures to the nearest degree. So that's the nearest whole number. And here's the triangle given. XYZ. And a 5 and a 9. That's all it's given. Now, based on what we've done in the last couple of weeks, you need side XY here. You need angle X and you need angle Y. You can start however you want to start. Meaning, you can solve for angle X first, subtract it from 90 and get angle Y, and then you can use the Pythagorean theorem to find side XY. So let's start that way for right now. We're going to say that the measure of X is equal to, if we're looking at angle X, we've got an opposite and an adjacent. And opposite and adjacent is tan. So we're going to go tan, inverse tan of the opposite side over the adjacent side. So if we take our calculators and type 9/5 second tan, we get 60.9. And we are rounding to the nearest angle measures to the nearest degree. So 60.9 gets rounded to 61 degrees. So we get 61 degrees. Measure of angle X is 61 degrees. That makes the measure of angle Y 90 minus 61. Did somebody get a different answer?
What did you do in the calculator?
Okay, I typed 9 fraction button 5 first. Then I pushed the green button second, and then tan.
Oh, okay, I got it.
61 degrees?
Yeah.
All right. So for angle Y, we're going to do 90 minus 61. 29 degrees. Now, in this case, I think the simplest way to find XY is to use the Pythagorean theorem. So if we do 5 squared plus 9 squared equals XY squared. 5 squared plus 9 squared. 5 squared plus 9 squared is 106. Find the square root of both sides. That's 10.29 rounded to the nearest side measures to the nearest tenth. So 10.3. All right, so here's our angle X. Here's angle Y. And here's the length of side XY. We good there? Okay. Now, let's look down to example 5B on page 572. triangle ABC. We got a 62-degree angle, and we've got side AC, which is the hypotenuse, that's 10. Now, we don't have that second side, but the measure of angle C is equal to 90 minus 62, which is 28 degrees. So we've got C. Now, we need AB and we need BC. So look, we're going to use Monday's lesson as our equation. So what I'm going to do in this problem is I'm going to look at this angle that I know the measure of, angle A, is 62 degrees. And I know that the hypotenuse is 10. And side AB, wouldn't that be the adjacent side? All right. So katoa, if I'm dealing with an adjacent side, if I need an adjacent side to an angle, and I know the hypotenuse, adjacent and hypotenuse is cosine. Now on Monday you wrote like cosine of A equals adjacent over hypotenuse. Well, we know what A is, so we can say cosine 62 equals the adjacent side, which is AB, over the hypotenuse, which is 10. So now, watch what we do here. We're trying to solve for AB, right? So if we multiply both sides by 10, this actually is fairly simple. The two 10s on the right-hand side, they cancel out. Now watch, in your calculator, when you're using sine, cosine, tangent buttons or inverse sine, cosine, tangents, it's just like the square root symbol. If you're using the TI-30XA, you got to enter the number first, don't you? So we're going to do 62 cosine. So 62 cosine times 10 and hit equals. And you should get a 4.69. So where's my cursor? So 4.69 equals AB. And I already forgot how we're rounding. Angles to the nearest degree, sides to the nearest tenth. So to the nearest tenth, this is 4.7, isn't it? So now we can use the cosine 62 again. But this time, well, I take that back. Look, you have two options here. One option is to now use the 4.7, the 10, to find BC using the Pythagorean theorem. Agreed? 4.7 squared times BC squared equals 10 squared. That might be the easiest way for you guys to do it. I'm just going to show you another way to do it. All right, we can still use this angle A, but instead of finding adjacent side over hypotenuse, we're going to find opposite side over hypotenuse. So opposite and hypotenuse is sine. So now we can say sine 62 equals its opposite side, which is BC, over the hypotenuse, which is 10. Multiply both sides by 10 again. And 10 times 62 sine equals BC. So 10 times 62 sine equals 8.8. So 8.8 equals BC. So here's AB, here's BC. Now, kind of what a quick check. Remember, the hypotenuse in a right triangle always has to be the longest side, okay? So make sure if you're solving for the legs of the hypotenuse that they're both, I'm sorry, the legs of the right triangle, that they're both less than the hypotenuse. Everybody okay with that? All right, so let's solve this next triangle 5C. PQR, P to Q is 16, angle R is 33. So the measure of angle P is equal to 90 minus 33. 57. Now you need two more sides of this triangle. So I'm going to use angle R. The 16, which is opposite, to find QR, which is adjacent. Opposite and adjacent. That ratio is tan. So tan 33 equals the opposite side, 16, over the adjacent side, which is QR. So now we've got two more steps since the side we're looking for is in the denominator. We're going to multiply both sides by QR. That cancels this QR, doesn't it? And then we're going to divide both sides by tan 33. So what happens is this QR falls down. The tan 33s now cancel. And QR is equal to 16 divided by tan 33. So take 16 divided by 33 tan, it equals 24.6. Bless you. So we got a 24.6 right here. Now again, you can use the Pythagorean theorem to find the third side, or you can use opposite over hypotenuse. You could use adjacent over hypotenuse. You could use sine, cosine, or tangent ratios. I'm just going to use the Pythagorean theorem. So 16 squared plus 24.6 squared equals PR squared. $861.16 equals PR squared, and then square root each side. 29.3 equals PR. And it's the hypotenuse, and it's the longest side of the three. So everything looks like it makes sense. Here's the measure of angle P. Here's QR. And here's PR. All right, so any questions on solving a triangle using trig ratios? QR. Okay. I got QR. Okay, go back. And what we have to do to get QR is we got to take this 16 right here, and we got to divide it by 33 tan. So clear your calculator, 16 divided by, and then type 33 tan and hit equals.
Oh,
All right, watch, guys. Yeah, look, when you don't hit equals, the number that's sitting on your screen is 33 tan, is tangent 33. That's the value that it is that you're dividing into the 16. So make sure you hit the equal sign, okay? If you use the square root button, it works the same way. If you don't hit the square root button, it leaves the square root of whatever you just tried to find on your screen. Better? All right. Any other questions about solving a triangle using these ratios? All right, then your practice for today is going to start on page 573. We got problem 15. And then 2 pages over, we got 42 through 45. And I am going to be out the next 2 days. So make sure that your geo facts get completed each day.